Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. And I would like to welcome you guys to the second experiment in the instrumentation process control lab, where in this experiment, inshallah, we will try to control liquid level inside this tank B2. Okay, so let's begin by reviewing the objectives of this experiment. So in the training manual, the objective is to operate the RT578 trainer in both manual and automatic control modes to control water level inside the process tank B2 at atmospheric pressure by manipulating water inlet flow rate to the tank using the variable speed pump P1 as an actuator. We will leave the second objective for now. Inshallah, when you come to the class or when you come to the lab, inshallah, to perform the experiment, we'll try to achieve the second objective. Talks about identifying the possible disturbances that might affect the liquid level inside the tank and examining the automatic control response under normal and abnormal operating conditions. So basically, as I said, guys, the control variable in our experiment is liquid level inside this tank B2, and in order to control the level inside this tank, we will manipulate water inlet flow rate to the tank. And this experiment, the tank is considered to be a fixed roof atmospheric tank, meaning that the tank is open to the atmosphere. Inshallah, we'll see how that is different from the pressure control experiment, where the tank will be closed and the pressure or air pressure inside the tank will be affected by the changes in liquid level. So for the liquid as a process, or liquid level as a process variable in the introduction, is defined as a measure of process liquid accumulation inside container, whether you're talking about storage tanks, distillation columns, fizzles, and etc. And they are usually expressed in terms of the height of liquid inside the container. طبعا the liquid measurements are so important, guys, in many chemical processes for different reasons. One of them is to make sure that some of the equipment will be protected against dry out conditions or operating under extremely low pressure. As we can see here, guys, one of the examples is that the liquid level inside this tank actually has got to be monitored, but it's not really part of the experiment. But in order to protect the pump against cavitation, and we have seen in process equipment that cavitation in centrifugal pumps is generally caused by extremely low suction pressures. There is a direct relationship between the suction pressure of water to the pump and the liquid level inside this tank. So if the level of water inside P1 is extremely low, then it is very likely that cavitation inside the pump might occur. But to prevent cavitation, we have to make sure that the suction pressure, which is related to the liquid level inside B1, is above the NPSH required, or the net positive suction head. Another reason for controlling and monitoring level inside the tanks is to make sure that material balance or material flow within the process and especially the downstream requirements are met. Now, as an example, guys, when you have a chemical process and you have a final product that is being produced, the final product, before it is sent to the customer, usually it is stored in tanks, okay? And just to make sure that the chemical or product supply to the customer is maintained regardless of any abnormal conditions that might happen inside the plant, will be maintained by considering an adequate stored level in the tanks. فعادة إذا كان في بعض المشاكل في البلانت، بعض المشاكل في المصنع، وتبي تحافظ على كمية الإنتاج اللي يرغب فيها الزبون أو الداون ستريم كاستمر، عادة إذا حصلت مشكلة داخل المصنع يتم سحب بعض الكمية من المنتج اللي موجود مثلا already في ايش؟ في الخزانات أو product storage tanks. The tanks and vessels are also used, guys, whenever we have equipment or systems like boilers and compressors, especially if you're talking about multi-stage compressors. Okay, in the multi-stage compressors, usually you have surge drums or you have knockout drums between the stages, because if you compress a gas and then you cool it down, it is very likely that some of the compressed gas, after it has been cooled down, some of the gas will turn into a liquid. بعض السوائل اللي ضغطتها وبعدين بردتها تتحول إلى سائل. And we know, guys, that compressors are designed only for gases, so you have got to separate the condensed liquid from the gas before you continue compressing or before you continue the compression process. So the manual talks about some of those applications in which liquid level measurements and control is important. طبعا شباب, the changes in liquid level inside the tanks depend mainly on two factors. Okay, if you have a tank like this and you'd like to understand what causes liquid level to change, the changes are basically affected by two factors. Number one is the material balance through the tank. Okay, how much is flowing into the tank? This is the inlet flow rate. How much is flowing in and how much is flowing out of the tank. كم الكمية اللي تدخل كم الكمية اللي تطلع. طبعا we know, guys, that at steady state operation, if the inlet flow rate and the outlet flow rate are supposed to be constant, and if that happens, then it is expected that liquid level would remain constant. إذا كان الكمية اللي داخلة نفس الكمية اللي طالعة، فبالتالي الحالة الطبيعية طبعا إنه يكون مستوى السائل ثابت داخل التانك ما يتغير مع الوقت. طبعا in case, guys, if both flow rates, the inlet and the outlet flow rates are constant, and you observe that the sensor that measures liquid level inside the tank shows a change, then it is very likely that you might have a problem in your system. One of the problems is that you might have a leakage, يمكن يكون عندك تسرب, or it could be a faulty sensor. يمكن يكون عندك sensor خربان ما يعطيك القياسات بالشكل الصحيح. The second factor is the geometrical shape of the tank. Sometimes we have tanks like this, cylindrical tanks, okay, and sometimes we have spherical tanks. التانك اللي على شكل السفير أو الكروي. الشكل يؤثر طبعا في مدى تغير أو سرعة تغير الليفل داخل التانك. طبعا in our experiment we have this tank which is cylindrical in shape, and we'll see inshallah how the shape of the tank will affect the change in liquid height inside. Okay. Now, in order to understand, as I said, the relationship between the inlet and the outlet flow rates to the liquid height inside the tank, we have those simple equations. Those are the mass balance equations. So, liquid level, this is the mass flow rate into the tank minus the mass flow rate out of the tank, and that will give you the accumulation, اللي هو معدل التراكم. طبعا we have studied in chemical engineering principles that equations must be always consistent in units. لابد ان تكون الوحدات on both sides of it. The equations are identical. The accumulation here, guys, is expressed in terms of the change in mass in kilograms per second, and we would like to relate liquid height. احنا نبي liquid height مقابل الفلو rate. But what we can do is we can divide both sides of the equation by the density of the fluid. If we do that, or if we do so, then we will convert the mass units to volume units. Okay, so we'll get the changes in cubic meters. Okay, and the accumulation inside the tank, if you look at it, guys, the liquid inside the tank looks like a cylinder because it's a cylindrical tank. Okay, now we can, or the accumulation of water inside the cylindrical tank can be expressed in terms of its height by applying the following equation. For cylindrical tanks, the volume is equal to pi times radius squared multiplied by the height of liquid inside it. Okay, and that's the form that relates the changes in the volumetric flow in and out of the tank to liquid height, because we know for a fact that the radius of the tank is constant. It is not a variable, whereas the height of liquid can change with time. You can see, guys, that the inlet and outlet flow rates, as well as the geometrical shape. I mean, as an example, if we have a spherical tank, then we need to express the volume of the accumulation of liquid inside the tank in terms of the spherical shape equation. Okay. Right. So we have in this process description a very a brief description of the process. Simply, guys, we have water that flows from tank B1, okay, and it is being pumped using the multi-stage centrifugal pump, and water flows through the piping system. Now, in this experiment, guys, we will not use the automatic control valve as an actuator. Okay, our actuator in this experiment is the variable speed pump. So the automatic control valve right now is fully closed, and we'll assume that it is not there. That's why the bypass valve B5 is fully open, as you can see right now. Okay. Now, after that, water continues to flow through the piping system. We have here the flow rate measurements, which is not our control variable. Our control variable is actually liquid level inside this tank. And water continues to flow through the pipeline until it flows into this tank. So as you can see right now, this is the inlet flow piping to the tank, and we have the outlet flow through this piping system, where this valve number 14, is partially open, and from there the water flows back again, as you can see here. Water flows back again to tank B1. Okay. Right. So yeah, so the liquid level, guys, the B14, as we said, will be kept partially open, so that causes some of the liquid to flow due to the static pressure of the liquid at the top. It will flow back again to the tank, and in order to control liquid level, we will manipulate the inlet flow rates to the tank using the centrifugal pump. Okay. Liquid level measurements, guys, is conducted using a guided wave radar level sensor. Okay. okay, which has a range of 0 to 700 millimeters. Okay, so that this is the level sensor right here, guys, and you can see that we have a rod inside the tank. I'm going to explain in a minute how this level sensor works. Okay, and as you can see, guys, the liquid level sensor measures the current level of water inside the tank, and the measured value is after it has been converted to an electric signal, it will be transmitted to the controller. Okay, so the measured value, as you can see right now, it shows 20%. The controller, whether it is the operator in the manual mode or the automatic controller in the auto mode, will compare the measured value with the set point, and based on the difference between the two values, it will decide what action needs to be taken, and that is in the form of sending an output signal. Okay, so here is the measurement that goes from the sensor to the controller, and based on the, as we said, the error or the difference between the two values, the controller will send an electric signal to the actuator, which is P1. Now, P1, guys, it's an electrically operated pump. Okay, so that's why we don't need an I to P converter. ما بين الكنترولر والpump, the actuator, we don't have an I to P converter, as you can see right here, guys. Okay, so we have this process, our tank, we have a level sensor, transducer, transmitter, then the signal is transmitted to the controller, and as we said, a comparison between the measured value and the set point will determine the output signal from the controller to the final control element or the actuator, which is our variable speed pump. We don't have an IP converter in between because it is electrically operated. Okay, so let's have a look at the way our wave radar level sensor works. Okay, so basically the manual says that the sensor measures water level by using electromagnetic pulses in a nanosecond range. Okay, the pulses are transmitted by a sensor head and guided along the road. When they hit the medium to be detected, the pulses are reflected back and guided to the sensor back again, and the time between the sending and receiving the pulses is directly related to the travel distance and so the current level. So what happens here, guys, is that this sensor right here, as we said, is connected to this rod. عندنا السنسر عصب الحديدية هذه. اللي يحصل الآن يا شباب إنه ترسل نبضات كهربائية electromagnetic pulses أو اللي هو نبضات إلكترومغناطيسية، تمشي يا شباب من خلال الرود إلين تصل إلى المنطقة اللي موجود فيها المويه، مباشرة تضرب النبضات هذه وترجع إلى السنسر. فبناء على المسافة، يعني طبعا النبضات هذه سرعتها ثابتة، فبناء على المسافة اللي مشتها النبضات هذه يحسب الوقت، ومن خلال الوقت يعرف بالضبط كم الليفل اللي موجود حاليا داخل التانك. طبعا this kind of measurements is very effective in industrial applications, and it is really done in as the training manual says, in a nanosecond range. يعني ياخذ لك يعني nanoseconds عشان يعطيك ايش القراءات, which is really a very good thing. طبعا in addition to that, guys, we have a direct local measurements, which is this ruler right here. هذا المسطرة تعطينا قراءة مباشرة من خلالها نعرف كم مستوى السائل داخل التانك. Okay. Now, there's something here that needs to be noticed, guys, is that the ruler and the rod inside the tank are not quite aligned with each other. يعني ما هم متواجدين على نفس الزيرو point. Okay. But if we want to convert the measured level in centimeters or millimeters to a percentage, we might find that there is a difference between the converted percentage based on the local reading of the ruler and the level sensor measurements shown here, which is 20%. Okay. طبعا شباب اللي هو based on the range of our sensor, it is 0 to 700 millimeters. If we want to convert that to an actual level, اللي هو height, then by using a very simple equation, we will find out that at 20% level, the or liquid height inside the tank is supposed to be somewhere around 140 millimeters أو 14 سنتي. جميل. نلاحظ الآن if we get closer, we can see that the ruler shows a value of around 15 centimeters. So we are 1 centimeter above the calculated value. Okay. Now, after discussing how the level sensor works, you can see that the system has already started. I have already started up the system, and I'm controlling the level right now automatically using the automatic controller. Okay, so let's have a look just at the measurements that we have to take during the experiment. Okay, so for the set points that we have, according to the procedure, we can do 20, 30, 40, and 50%. Okay, the process value is supposed to be the same. The automatic controller or the manual controller must make sure that both values are the same. And we'll also take the controller output signal reading. Along with that, we will look at the discharge pressure of the pump, and that will be slightly different from what we have seen during the flow rate experiment, guys. In the flow rate, if you remember, the pump was running at a fixed speed, 100% maximum speed, and the flow was adjusted using the automatic control pump. Okay, so during that time, we have seen that as we increase water flow rate inside the system, the discharge pressure of the tank was decreasing. But in this experiment, we are not using the control valve. Actually, water is being bypassed. And we will see that there is a direct relationship between the discharge pressure of the pump and water flow rates. اللي هو باستخدام variable speed pump. Okay. A fixed speed plus control valve in terms of discharge pressure versus flow rate is the opposite of using only the variable speed pump. For variable speed pump, there is a direct relationship between the flow and the discharge pressure of the pump. Okay, and along with that, we also have the flow meter indication that is right here. Okay, and along with that, also with the help of the ruler, we will record liquid heights. Okay. So right now, as you can see, gentlemen, the system is currently running, and the first set point has been achieved, which is 20%. The system is at steady state, almost steady state condition, with liquid level being measured at 20%, and the output signal is 5.9. Okay, so if you want to take the readings, so the process value is 20%. The output is fluctuating just a little bit, but for now we'll say it is around 5.9%. Okay. Along with that, we have the P1 discharge pressure, and as you can see right now, compared to 6 bars in the flow experiment, discharge pressure is barely above 0.2 bar. Okay, so it's very likely to be around 0.3. The flow meter indication is somewhere around 942. We'll take an average value. Okay, this is a high sensitive flow meter, and liquid height is 15. It's showing 150 millimeters or 15 centimeters. Okay, theoretically speaking, guys, الناحية النظرية, okay, as we said when we talked about the sensor. Okay, so this is our sensor right here. We said that the guided wave radar level sensor has a range of 0 to 700. Theoretically speaking, at 20% level, the theoretically measured level is supposed to be around 140 millimeters, or 14 centi, or 14 centimeters. But as you can see here, it is due to the fact that the ruler and the road are not really aligned with each other. They don't have the same 0 point of reference point. Okay, so now if we go to the next set point, let's have a look at how the system responds to a change or to a change in the set point. So let's go back to here. Okay, and as you can see, guys, both the process value red and the set points in red, and the process value, if you get so close, yellow, they're almost on the top of each other. Okay, which means that both of them are at 20%. And this is the green line that shows the output signal. Let's make a change in the set point and try 30%. Okay, so I have changed the set point, and just look at the trend. You can see right after I changed the set point, the controller started to make the calculations, so there was 10% error, and as a result of that, an instant change in the output signal has been made. أول ما حولت إلى 30 كانت تقرأ 20، فكان عندي يعني 10% error. In order to increase the level, the controller sent a signal, has increased the output signal بالأخضر. Let's go back here. You can see right here مباشرة زاد output signal اللي من controller. This is the signal that goes from the controller to the final control element, which is the variable speed point. فمباشرة بدأ الليفل يرتفع عندنا الآن. And if you look at the trend back again, as well as the values, you can see that the system is now approaching 30%. Okay, but it might take some time. It might take a few minutes for the system to stabilize and show steady state conditions. As far as I remember, guys, that the level sensor was showing a little bit of fluctuations in the past. كان في بعض الأحيان يرسل قراءات أو كان في بعض fluctuations. So we might notice that the process value will keep fluctuating up and down by somewhere around 0.5%, plus and minus 0.5%. يطلع وينزل كل شوي. It could be due to the presence of, as an example, solid materials on the road that might affect the electromagnetic pulses that travel along the road. النبضات الكهربائية الآن اللي يحصل السنسر كيف يقيس الآن يرسل نبضات كهربائية أو إلكترومغناطيسية تضرب على سطح المويه بالشكل هذا وترجع. جميل. ومن خلال مثل ما ذكرت المسافة أو حسابات الوقت والمسافة يعرف أو the measurements is converted to a liquid level. Okay. So as you can see right now, the system is almost at steady state condition. لاحظوا الفluctuations هذه بشكل بسيط جدا. And the output signal has slightly increased from 5.9 to 7.5. Okay. The discharge pressure has barely changed. Okay. يعني يدوب تغير بشكل بسيط جدا لأن التغير في الاوتبوت سيجنال كان بسيط جدا للأمانة. So if we go to a higher set point and then try to introduce a disturbance to the system, we will see how the output signal changed according to that disturbance. So if we go now and increase the set point to 40%, you can immediately notice the change in the output. Output side of it. That means pump speed is now increasing. لاحظوا هنا شباب مباشرة أول ما غيرت الست point, the red one. Again, same thing, calculations. Okay, 10% error. That causes the output signal to immediately increase. And the controller right now is trying to adjust the final value of the output. بناء على إيش؟ بناء على الإيرور. So it might take a few minutes for the system again to stabilize. Okay. We'll just wait a few minutes. As you can see right now, it is somewhere around plus 0.1% above the point. And the higher the set point, as we are going to see inshallah, means longer time for the system to stabilize. كل ما وقعنا في الست point كل ما زاد الفلو ريت كل ما كان الوقت اللازم عشان يرجع السيستم بحالته الطبيعية ياخذ وقت أطول. طبعا if you look again at the gauge, you can see that it is almost approaching 0.4 bars. Okay. And the output signal has only increased by 2% approximately. So if we take if it takes longer than usual, guys, then and if it feels somewhat inconvenient for you as an operator of the system, then you can switch to the manual mode. That's where the output signal is manually changed. Okay, لاحظ الاوتبوت signal ثابتة. That's why, or that's I made this change. I switched to the manual mode to show you that even at a constant output signal, سرعة البمب الآن ثابتة. نلاحظ الفلكشويشنز هذه كانت موجودة. Fluctuations في الاوتبوت is due to the fluctuations in the process value, as you can see. فلاحظوا يا شباب, even with a constant output, لاحظ الاوتبوت ثابت ما يتغير. You can notice that we still have some fluctuations in the level measurements. Okay? That tells me right away, guys, that everything is constant. البمب سرعتها ثابتة. This valve is open at the same degree. You can see it's around 25 the opening of the valve. ما تغير فيه أي شيء. You can notice that liquid level here is almost constant. It's not changing. It's 29 centimeters. But the measured level is constantly changing. Okay? That gives you an indication that there is a problem with the sensor itself. Okay? Let's go back again to the automatic mode. Again, we'll do the same thing, taking all the required readings, and from there we will go to the next set point, which is 50%. I might have a chance to introduce a disturbance, okay, and see how the automatic controller responds to to that disturbance. Okay, the disturbance will be done by changing the opening of this valve إن شاء الله. راح أحاول إني أفتحه. Yeah, تقريبا I will open it more إن شاء الله. But if I open this valve more, guys, you'll expect more water to flow out of the tank, and that causes the level initially to drop. فتحت الفالف هذا الاوتلت راح يبدا ينزل عندي الليفل، يعني كل ما فتحت اكثر كل ما زاد الاوتلت flow rate. We will see that as a result of the drop in water level inside the tank, the controller will increase the output signal, okay, and that will cause the pump to run at a higher speed. راح يزيد سرعة البمب عشان يزيد ايش؟ الانلت فلو ريت ويتعادل مع الاوتلت فلو ريت ويرجع الليفل على الست بوينت المطلوبة. We will see that إن شاء الله in a minute. Okay, طبعا as you can see now, right after the set point has been changed from 40 to 50%, again I've got a change in the output because of the error. لاحظوا الايرور هنا في النقطة هذه اللي هو الفرق ما بين البي في yellow line and the red line. فمباشرة increase the output signal, and it continues to measure and calculate the proper response or action in terms of the output signal to the pump. Okay. You can see right now at 50% it is getting now stable, reaching a new steady state operating point at 50%. You can see right now that the output signal is around 10.5%. The flow rate is now, compared to the previous value, is higher. Okay, and at 50%, guys, theoretically speaking, it's supposed to be around 35 centimeters or 350 millimeters. You can see that it is around how much? 336 centimeters and maybe 3 millimeters. 336 millimeter أو 36 سنتي و3. You can see right now, guys, this gauge is a pressure gauge that measures air pressure inside the tank. Okay, and because this valve during the experiment is kept open, okay, when liquid level rises inside the tank, some of the air will be pushed out of the tank, so we don't expect any changes in air pressure inside the tank. But next experiment, inshallah, with pressure control, we will close this valve. Okay, the air will be trapped inside the tank, and as a result of that, we will notice that the pressure will changes, or the pressure will change directly with the increment in liquid level inside the tank. Okay. Now, the system, as I said, has reached a new steady state operating point. It is now 50%. There is a very small change, as you can see, in the output signal of the controller, which is the signal that goes to the pump. Okay. Now, last thing I would like to show you guys is basically trying to demonstrate the second objective of the experiment, is identifying the possible disturbances that might affect the control variable and examining the automatic control response to that disturbance. So with liquid level measurements inside the tank, considering that the tank is open to the atmosphere, actually we have probably one disturbance, and that is the liquid outlet flow rates from the tank. Okay. But then for the upstream or liquid inlet flow rate, guys, we'll assume that it has been everything upstream of the tank is working in perfect conditions. The pressure الليفل هنا قبل ثابت، البريشر هنا ثابت، ما عندي أي مشاكل. I assume that everything is perfect. But as a matter of fact, guys, any changes in this level, on the liquid level inside this tank B1, the collecting tank will definitely change the suction and discharge pressure, and that will definitely affect the output signal. Okay? The disturbances that we might have is basically the outlet flow rates, okay, from B2, that is going back to B1. And because we don't have, or we are not willing to make any draining in, from B1, we'll assume that liquid level in tank B1 is constant and it is not a potential disturbance. فالdisturbance اللي بيكون عندي بالتجربة هذه هو فقط outlet flow rate, which will be introduced by changing the position of B14. راح افتح اكثر بنشوف كيف يتغير معي الليفل وكيف الاوتوماتيك كنترول سيستم يبدا يستجيب. I will keep the set point at 50%, okay, because the output signal is slightly low. We don't have to worry that much. You can see right now that the level is constant. It is at around 56 and something. The discharge pressure is barely around 0.4 bar. Okay, and water flow rate is 1,000, somewhere around 1,090 liters per hour. Okay. But so let's do the following. Okay, I will open this valve more. Okay. Let's see, I just opened. Liquid level started to go down, as you can see. Okay, so that is a disturbance, guys. I was running in steady state condition and someone opened the valve. So the process value and set point were together here. And the moment I opened V14, liquid level started to drop. أول ما فتحت V14 الليفل بدأ ينزل. The sensor immediately detected that. Okay, and the controller, based on that detected change or the changes in liquid level, immediately decided to balance the flow rates and bring back the PV to the set point to increase the output signal. فاللي حصل إنه لما فتحت الفالف 14, more water started to flow out of the tank. Okay. The sensor gas مباشرة measured the changes in liquid level, and the controller immediately decided to increase pump speed. So now the system is trying to bring back the process value to the original steady state set point 50. In the past or before the disturbance was introduced, the output was somewhere around 10%. Okay, and now when we reach again 50%, you will see that the output signal is no longer 10. It is actually around 18.3%. So that's why we need control systems, guys, is that based on a given set point, okay, the control system will try to make sure that the measured value of your controlled variable, this is the measured value, is matching with the set point. And that is done by manipulating a variable in the system. Okay. In our case, guys, the manipulated variable is water inlet flow rate to the tank. The manipulated variable is water inlet flow rate to the tank, and the flow rate is manipulated using the variable speed pump as an actuator. Okay. So yeah, so you can see right now the process value is now, after the drop in liquid level, it's now going up to me, and we have now the same process value matching with the set point, but we have now a higher output signal. Okay. عندنا ايش الاوتبوت signal الان صارت اعلى من قبل، كانت تقريبا 10 point something, now it is around 18%. Okay. Yeah, if we continue doing the same thing, guys, you'll see that again the system will do its best to return the process back to the original sequence. Okay. Thank you very much, and inshallah, hopefully once you watch the video and read the training manual for the liquid level control. Inshallah, when you come to the lab, we will immediately perform the experiment. Thank you very much, and I definitely expect some questions to be asked during the experiments. يعطيكم العافية شباب ونتمنى لكم التوفيق إن شاء الله.